Hey YouTube! Okay, so I've decided that I'm going to do a little video about how PouchTV works. This is totally just a spur-of-the-moment thing. It is completely unrehearsed, so if it comes off as a little unpolished, then don't be surprised. But I was just thinking recently that it's really hard to get contributors to PouchTV, and I find that surprising because to me, like, the code is just so simple, easy to understand. But then I realized, like, when you're staring at a huge pile of code, like, there's a big mountain to climb in terms of understanding what that code is doing and how it's laid out. So that's kind of the goal of this video, is to just provide, a big high-level bird's-eye view of the code. Some information for people who may be curious about how PouchTV works, or people who are interested in getting started in the project, as I did a little over a year ago now. It's totally approachable. It's not that hard. It's really well designed, and I can't take any credit for how that's designed. A lot of that predates me joining the project. But anyway, it's really cool. So let's dive right into it. So I'm also going to be doing some new stuff here. I've got, maybe you can see this, I've got this nice little drawing tool on my Nexus 7. And this is neat. It's actually casting. Yeah, it's casting to the screen. So we'll see how well this works. I'm going to be drawing with my finger though. So this is a very imprecise tool. We'll see how it works out. Anyway, so I'm using AllCast for this, by the way. So go and support Kosh and his apps because he writes awesome apps. AllCast is amazing, and this is the mirror app that he also wrote. Anyway, okay, so let's talk about PouchTV. So, okay, high-level view of how the project works. Let's just talk about what it does first. So PouchTV is CouchDB re-implemented in JavaScript, and that statement right there doesn't explain a whole lot about how it works because it doesn't explain what environments it runs in, things like that. I mean, JavaScript runs just about everywhere these days, so it's really important to qualify that. So at a high level, there's basically two ways that PouchDB works. So let's draw it out here. So at a very, very high level, there's basically two ways that this thing can work. It can work as a node module. That's the word node that I tried to draw with my finger. Or in the browser. Right? Now where this gets complicated is that in Node we basically have free reign to use whatever storage mechanism we want, right? And in this case we happen to use LevelDB because it's just kind of the standard in Node. So that's level. And then in the browser, it's a little bit more complicated. If you've looked at the Can I Use page for IndexedDB or WebSQL, you'll see that it's kind of split between the two. So basically, we've got really good WebSQL support on mobile, but really good IndexedDB support elsewhere. So we use IDB in some places and WebSQL in other places. So basically, when you fire up PouchDB, it's going to be using one of these three by default. If you're using it in Node, i.e. you did npm install PouchDB, then it's going to save those files to LevelDB. If you open it up in a browser, then depending on what browser you're using, it's either going to be saving it to IndexedDB or WebSQL. And it does this through what we call adapters. So I'm going to show you what this looks like right now. So if you go into the PouchTV codebase, so I've got it open here in WebStorm. Let's just see if I can maybe zoom in a bit. I think there's, hang on a sec. No, that's not it. I know there's a way to zoom in. Yeah, okay, there we go. Okay, so if you look at the project from a really high level, you'll see there's this lib directory, which contains all the source code. Okay, and one of the subdirectories is adapters. And you'll see there's 4 adapters in here. So the one I didn't mention was HTTP, which is just basically using PouchDB as a client to a remote CouchDB or Iris Couch or Cloudant or Couchbase Sync Gateway or what have you. So in the browser, you've got these two ones right here, IDB and WebSQL, and then in Node, it defaults to LevelDB. And the way that these things look, actually, it's really easy to understand. Like at a high level, you can just kind of look. They're kind of organized a little bit differently. We started kind of modularizing them a little bit more. So some of them have been more modularized than others as we go in and kind of clean up the code. So you can see IDB, IndexedDB, is a bit more modular than the other ones. HTTP less so. But we're making progress slowly but surely. So the way this works at a high level is that each of these basically almost completely represents a full CouchDB implementation. So if you look at a really simple one, let's take web SQL because I think that's the simplest one. So if you look at this guy from a really high level, let's just zoom back out. What it's doing is it's declaring an API. If I skip all the required functions, okay, it exports a function called web SQL pouch. Okay, and what this thing does is this delivers an API. If I skip all the migration code, that describes what this CouchDB-like database should operate like. So, for instance, if I scroll all the way down, okay, so it's got functions like that will look very familiar if you're used to working with CouchDB. So it's got functions like bulk docs, right, which is for putting in many documents. It's got a function called get, right, for getting a single document, and this contains the entire implementation for that get method. So, in fact, there's all the option parsing is done right here, right inside of the adapter itself. And each adapter has exactly the same methods. There is an informal spec for these. We haven't actually sat down and written out the spec how it works, but you can just kind of look at the code and it's pretty clear what's going on. So for instance, if we compare websql.js to idb.js and we search for bulk docs, you will find almost exactly the same kind of structure here. In fact, actually, WebSQL looks really similar to IDB because I think Dale just copy-pasted IDB and then just slowly changed the bits that needed to be changed for WebSQL. LevelDB looks a little bit different from the other ones, but you would see that if you looked at the code. So, I mean, there's a get method here. There's a bulk docs, get attachment. That's an IDB-specific thing. That's IDB-specific. That's IDB specific. There's an allDocs method right here, which WebSQL also shares. So allDocs, the thing that gets many documents, right? So these adapter definitions get loaded into PouchDB by way of the list of preferred adapters. This is kind of a thing under the hood. So basically the way it works is this, is that PouchDB maintains a big array. Let's look at this. So if I bring up, just trying to think of a random site that has PouchDB. Let's go to Done Good, which is Dale's little to-do app. This is a pretty good resource. Let's bring up the console. And let's zoom in on this bad boy. Let's actually zoom in. Okay. All right. And let's fire up a new PouchDB. So to do that, I'll just do vardb equals new PouchDB. And because I'm doing this in Chrome, this thing is going to be using IndexedDB. And the way you can tell is you just do db.adapter, and it says IDB. So PouchDB under the hood has this special property called preferred adapters, which is going to vary from environment to environment. Basically, it's just going to vary from the browser to Node. Inside of the browser, it'll have this list of IDB or WebSQL, and what these map to is the list of PouchDB adapters. So this is just an object that contains all the possible adapters that are available in this particular browser. So what PouchDB is going to do is when you start up a new database, it's going to just march through the list of preferred adapters and it's going to try each one and see if it's valid. Each of these adapters exports a function valid that just says whether it works or not. And basically that's just to tell us that WebSQL doesn't work in Firefox or IE, and that IndexedDB doesn't work in Safari or iOS or old Android, things like that. And yes, Apple has implemented IndexedDB, but as of this video, me recording this today, February 15th, 2015, it is still broken enough that we have chosen not to use it and to fall back to WebSQL instead on Apple devices. Anyway, so you can see there's 4 different adapters here. There's HTTP, HTTPS. This is the HTTP adapter. And that one as well, if I zoom out, that one also implements all the same functions. So it's really, really easy to understand what's going on. It's not easy to understand what's going on my screen right now because I'm messing this up. But let me just... let me try to... Oh, man. I don't know how to use my own mouse. This is terrible. Okay, all right, I'm zoomed out. Okay. All right, I hope you didn't get vertigo from that. I'm really sorry if you did. Okay, so let's go back to the code. Let's look at http.js. If we look through this thing, we'll see the same bulk docs function, all docs, but you'll notice that it's a lot less code than the other ones, and that's because all it has to do is just proxy to CouchDB. All it does is just make an AJAX request. So let's look at a really simple one, for instance, not the changes, maybe get's pretty simple. There's no get. I'm not really sure how this is implemented then. Well, there should be an all docs. Oh, come on. Oh, there's a changes, right? Where's all docs? Oh, okay. Oh, that's right. Okay, I forget what the distinction is between the underscore all docs and the regular all docs. I think it has something to do with turning it from a callback to a promise, I believe. All that is handled in adapter.js. Anyway, I'm getting ahead of myself. So there is an all docs function. All right, all it really does is it parses a bunch of options. It turns the options that are user supplied in a JavaScript object into just HTTP parameters. Like this should look familiar to anyone who has done AJAX in jQuery before. Super simple, just parsing the params, and in the end just does AJAX to CouchDB or to whatever remote server we're talking to. So in that way, we have 4 different adapters, right? We've got HTTP, LevelDB in Node, IndexedDB in the browser, and WebSQL in the browser as well. And all 4 of these things expose more or less the same API. And they just describe how to interact with the actual underlying data store that actually saves stuff to some disk somewhere. Or in the case of the special InMemory adapter, it doesn't save it anywhere, but I'll explain that later. So if we go back to the console, and I'll show you what's going on in this adapters list. So you'll see there's an HTTP and an HTTPS adapter. And actually that's just sugar, because they're both exactly the same thing. But just one of them is if you're using HTTPS, the other one is if you're using HTTP. There's also the IDB adapter and the WebSQL adapter. And as I said, they will both expose a valid function, explaining whether or not they're valid. So if you go into websql.js and you look up valid to see how we decide whether something is valid, it looks like there's a util function. Okay, here it is, function valid. Which is really simple. All it does is it checks to see if there's a function called openDatabase, which is what's used to open up a WebSQL database. It's not defined in Firefox or in IE, so this immediately tells us, okay, that those browsers don't support WebSQL. The only exception is the SQLite plugin on Cordova or PhoneGap, where you actually can use SQLite as a backing store in Windows Phone 8, which normally doesn't support WebSQL. But through the magic of the SQLite plugin, you actually can use a WebSQL-like API, which is really neat. So we just look for those 2 cases, and that's how we tell whether it's valid or not. IndexedDB, if I recall, is a little bit more complicated in how it determines whether something's valid or not. Yeah, this is where we have our ugly... Yeah, this is where we have our ugly user sniffing and all this stuff. User agent sniffing. This is not great, but this is what we have to do. So this entire function just returns whether or not we think that the browser actually supports IndexedDB or not. So you notice that the list of preferred adapters listed IndexedDB first and then WebSQL. So that's where it comes in, where we say, all right, we fall back from IndexedDB to WebSQL and not the other way around. You can fall back from one to the other, and in our documentation, there's plenty of descriptions of how to do that. But at a high level, by default, we prefer IndexedDB. So if you look at LevelDB, it too has a valid function, but I believe it just returns true. Okay, actually, it just says, are we not in a browser, right? Which actually, this isn't even necessary, because we don't even export the LevelDB code in the browser-fied version of PouchDB. So I should step back a little bit. PouchDB is built using browser-fi. So if you check out the code, it's really easy. You get the code from GitHub. You do npm install, which I've already done, and then you do npm build. And what that does, npm run build. And what that does is it runs browserify, and it builds up PouchDB.js. It minifies as PouchDB.min.js. It also builds up all the adapter plugins, which I will talk about later. Plugins such as the InMemory plugin, or the LevelJS IDB alt plugin, or the local storage plugin. It builds up those as well. But at a high level, it's all browserify. And you can see this. Actually, the code is very simple and very modular. You want to see what the index.js looks like for PouchDB? It is super simple. It's in lib index. Where am I finding it? There it is. This is the entire code. This is the root JavaScript file for all of PouchDB. So, and this is pretty easy to understand, so actually I can just go through it right here. So what we've got, so we export a function called PouchTV. So if you actually use this with Browserify, then you can use it in such a way that you don't clobber the global window variable. You can just, so window.PouchTV won't be defined. You can totally do that because we just export the PouchTV constructor. We have a little helper called Ajax. We've got a bunch of utils, which is this line. Errors are also kind of a util. This is just some sugar for different errors, 404, 409, things like that. The replicate algorithm and sync algorithm, which I'll get to later, what version of PouchTV we're running, and then the adapters, the really interesting part. So to write a PouchTV adapter, actually you can write it as a plugin, in fact, and all you would need to do, no one's done this yet, but it's totally possible. I mean, well, no one's done this outside of the official plugins that we officially release with PouchTV, but it's totally possible. You would just write an adapter that exposes exactly the API that I showed, like with bulk docs, all docs, the basic CouchDB goodies that you would expect from a basic CouchDB implementation. You just call PouchDB.adapter, give it a name, and pass in your adapter. That's all you got to do. So that's what we do in the main file here, right? So we've got HTTP and HTTPS, which are exactly the same adapters. So you saw those. We've got IndexedDB, which we name IDB for short, WebSQL, and then that's it. That's how adapters are added. And so I'm actually gonna jump into this a little bit just to show you, because I think it is interesting how the plugins work. So I've been building this in the background, and it should be done by now. So what it'll build is in the dist directory. If I zoom in a little tiny bit, maybe. Yeah. So in the, let's just make the font bigger, huh? How about that? Okay. So in the, let's put it over here because I know my face is like right in the lower right hand corner, right? I made this mistake the last time I made one of these videos. I didn't realize that my noggin was blocking some of the screen, so I'm going to try to avoid that today. Anyway, so if you look in the dist directory of what we just built, there's the two most crucial things, which are PouchDB.js and PouchDB.min.js, which are just, that's PouchDB. That's the basic PouchDB file that you download when you want to use it as a browser script. But there are also these little plugins here, right? There's the IDB alt one, which is based on LevelJS, which is just kind of an experimental thing. You probably won't ever need to use it. The local storage plugin, which is really cool because that lets you support PouchDB all the way back to IE8. So that's really neat. And then the InMemory plugin, which is also neat. That's great for unit tests, and I know it's been used as a replicating cache so that you can have faster access to your database, which is really, really neat. And these things, the way that these are built up is literally the entire code is just basically what you saw here. Like we bundle up this separate adapter. We call PouchDB.adapter, give it a name, and just pass it in. So actually, if you want to see how this looks in practice, let's actually try this out. I don't think I have any code on me that does this already, but you know what? I'll just make one right now. So let's let's go ahead and let's make an index.html. Basic index.html, and let's put in PouchTV, right? And then let's also put in the plugin. Let's put in the memory plugin. Why not? The InMemory plugin. Okay, so now if I open this guy, I think that's correct, right? Let's just do a Python m simple HTTP server. We'll open on port 8888. Okay, so if I go into the console, hopefully there are no errors. Looks like there are no errors. Okay, let's zoom in on this so you can see better. Okay, so let's create a PouchDB. If you look at this thing, it's still using IndexedDB, right? So it seems like nothing has changed. To use the memory adapter, you would say new PouchDB, my database, and you would pass in adapter memory. Okay. So now what's our adapter? Memory. Okay, so what's changed here? This would totally not work if you didn't have the plugin installed. What's changed here is that this special PouchDB preferred adapters thing has been changed. So instead of being a list of just two, IndexedDB and then WebSQL, we have IDB, then WebSQL, then memory. So actually, if you open this on a browser that didn't support either IndexedDB or WebSQL, such as IE 8 or IE 9, it would just default to an in-memory PouchDB, which is actually kind of neat. Like, you can totally do that. There's no reason not to do that, except that the in-memory plugin actually takes up a lot of space. So that would be the only reason you might not want to do that. Because when it gets browserfied, it pulls in a lot of stuff that we don't need in PouchDB core, and I'll explain why that is in a bit. But anyway, so then if you look at the list of PouchDB adapters, you'll see we have an additional one that we didn't see before, which is the memory adapter. So that's where this MagicString memory comes in. And for local storage, the MagicString is local storage. For IDB alt, the MagicString is IDB alt. Like, it's pretty straightforward. The one thing that might be kind of confusing here is you may be wondering why HTTP and HTTPS aren't in the preferred adapters. Really, preferred adapters is kind of a misnomer. It's more like preferred local adapters. For remote, we always used HTTP. This one adapter, the HTTP adapter, has served us well for Couchbase Sync Gateway, Cloudant, CouchDB. So we just use it for all three. PouchDB Server as well, so all four, I guess. So I mentioned that the one reason you might not want to use the in-memory plugin is because it's kind of huge. So let's see exactly how huge. So here are the sizes of all these, and yeah, you can see that it's kind of silly because the plugins are actually bigger than PouchDB themselves. The reason for that is that the way that this is built, and actually you can see it in the comments if you open up PouchDB.memory.js. Excuse me. Yeah. You can see it. It says right here, PouchDB in-memory plugin based on MemDown. So the way that this works is if I go back to my little sketch pad. So I've got on the left here, I say that in Node we use LevelDB. But actually it's kind of a fib, because what we're actually using is LevelUp. So the LevelUp project, maybe I can find this page as well. Node LevelUp, it's called. Yeah. So there's a project created by Rodbag, Node LevelUp. And there's a corresponding project, a sister project, let's say called LevelDown. And these are kind of confusing nomenclature, but basically what it is LevelUp describes the API for interacting with a LevelDB-like database. And LevelDown is the actual bindings to LevelDB itself, implementing that API. So they actually have a very similar setup to us. It's kind of neat. And these developed relatively independently, but I guess we just both decided it was a good idea. So what they do is in their community, they describe an API that is very similar to LevelDB. It's kind of LevelDB tailored. And LevelDB is a really low level database, no pun intended. So it works pretty well for just about any embedded data store. They define this API in LevelUp, and then they have many adapters that are usually called something down. Like there's LevelDown, there's local storage down, which runs in the browser. There's memdown, which is in memory. And those are the two that we use for the local storage plugin and the in-memory plugin. And actually, we've contributed a lot to those projects. So they've kind of grown along with PouchTV, which has been really neat. There's many more. There's level.js, which is an IndexedDB implementation on top of LevelDown. There's a ton of these things. Actually, I can't even keep track of them because they just add more all the time. But there's a list that they maintain. And if I look it up, let's see. Yeah, there's a full list. So, okay, somebody even implemented LevelUp for CouchDB. So you could use PouchDB through LevelUp through CouchDB, which is totally nuts. You should not do that, but that's kind of neat. But apparently that's possible. That's really crazy. Oh, okay. Actually, maybe I'm mistaken. Sorry. Here are the actual backends, the down implementations, as I call them, because they're mostly called something down. So yeah, so there's LevelDown, LevelJS, which is IndexedDB local storage down, indexed up, I guess. Okay, this is another IndexedDB implementation. Memdown, JSON down. JSON down, there's a really neat one because that one is dead simple. That's an implementation that just uses Node.fs to write JSON blobs, like just just JSON plain text to the file system and then reads it back out. So I mean, it's totally unperformant, but I mean, you could probably get that to run just about anywhere, right? It doesn't require a whole lot. MySQL down, Azure LevelDown. These are all so neat. SQL down is really cool. Calvin Metcalf worked on that one a bit. That one's really neat because that works over just about any SQL database, and in particular, it works over WebSQL and SQLite. So that's really neat. You can use that in a variety of scenarios. React down, Redis down. So yeah, so if I go back to my little drawing, so actually what we're doing here, let's zoom in on this left side right here, in a sense. Let's zoom in on the node level side and see what's actually going on. So actually what PouchTV actually does, is in Node, we've got Pouch right here that talks to LevelUp. And then by default, it uses LevelDown, which then that thing is built on top of LevelDB. LevelDB. There are also some forks of LevelDB you can use. They weren't listed there, but there's Facebook has one called RocksDB. I think it's a fork of LevelDB. There's another one that I don't remember the name of. That's the one that Basho uses for React. But anyway, you have lots and lots of options, which is really neat. So basically, if you want to, you can use PouchDB over LevelUp, over any number of different things here, right? Like memdown or React or whatever. For the most part, you only have to get your hands dirty with this if you're using PouchDB in Node, and we have some instructions on the wiki for how to do that. It's all just it's pretty easy to do. It's all just require this and then you pass it in as an argument, I think. So if I look at adapters.html on our guide, Node.js. Yeah, so for instance, if you want an in-memory database in Node.js, it's really easy. You add memdown, and then you just pass it in to PouchDB as a DB option. This is different from adapter. So it's funny. There's only 4 PouchDB adapters in existence right now. Right? HTTP, LevelDB, IndexedDB, and WebSQL. The LevelDB one, though, its name is kind of a misnomer these days because, I mean, it originally was just LevelDB, but now it actually supports all of these crazy down implementations as well. So, but we hold on to the name for backwards compatibility. So when you create a database in this way in Node, its adapter will be LevelDB, but this DB option that's a LevelUp thing. Like they sort of standardize that you pass in this option called DB, and then that points to whatever down implementation you want. So this PouchDB that we'd be creating right here, this thing would have an adapter of LevelDB, but under the hood it's actually using memdown. And if you do db.info, I believe that info comes back. But that's how that's implemented. So yeah, you have to get your hands a little dirty when you use it in Node. You have to actually require stuff. It's not very hard though. I mean, look at that. It's 2 lines of code, or 1 line of JavaScript. In the browser, we try to make it a little bit easier. So we actually bundle these things up for you. We bundle up the local storage plugin, the memory plugin, and the LevelJS based plugin, which is just kind of experimental. So all you need to do is include those script tags in your page and you're good to go. So that's sort of a whirlwind tour of the PouchDB adapters. So the other interesting thing, if we go back to the index.js, the other interesting thing here is that you'll notice that if you look at the adapter-specific code, you'll notice that none of them actually implement sync. So sync itself is actually just a separate file, a separate algorithm that's written totally on top of this sort of minimal CouchDB API that each of the adapters exposes. So if you look at how we implement replicate, so you can see we just require right here, there's a replicate script. Sync is kind of just written on top of replicate. It's sugar for replicating 2 databases at once bidirectionally. But if you look at the replicate implementation, so this is this replicate.js, let's look at where this is. Right, so this is lib replicate.js. This is the entire PouchDB replication implementation. And it's, let's see, like 600 lines of code, not counting the checkpointer, which is included separately, which writes checkpoints. But that's not very much code either. Look, that's not even 100 lines of code. So the way that this thing works, actually, this is described, this implementation of CouchDB replication is pretty well described in the TouchDB documentation. So we basically just stole it from them. I didn't write most of it actually, so I didn't steal it from them. I guess Dale or whoever wrote Replicate. I don't even know who wrote it. Stole it from this. This is so this is from the TouchDB documentation. TouchDB, by the way, is the precursor to Couchbase Lite. Yes, Couchbase Lite for iOS and Android. And I didn't realize it was written by Jens. Anyway, so this describes the replication algorithm, and this works for any couch-like implementation. So it works for PouchTV, works for our couch, works for PouchTV server, and it only requires that the couch-like API, in our case the adapter, implement 4 methods. And those 4 methods are, if I look at replicate.js, I believe it's revsdiff. Yes, revsdiff. Get. Yeah. Changes, I think, and bulk docs. So basically the way that that's going to work, let's actually draw this out. So basically the way the replication works is, okay, can you see that? It's going kind of slow. Okay, so at a high level, you've got these 2 databases. See if I can draw a little cylinder representing these things. And say you want to replicate from left to right, okay? The first thing you do is you get a list of changes. So I'm just type text, can't I? Oh, I don't want to do this. You get a list of changes. And then for each change, so this is from the source database, for each change from the source database, you ask the target database, hey, do you have these documents and these revisions? And that's what revsdiff is. So revsdiff is like revs difference, right? Like, I've got these revs, what have you got? And then the target database responds and says, hey, I know about these revisions for these documents, I don't know about these revisions. So then the source one says, okay, well, I guess I'm going to have to do a get for all of those. So it does a get for each of those, and then it goes back to the target database and does a bulk docs. And actually in our implementation, in PouchTV's implementation, we don't even have a post or a put actually implemented at the low-level adapter level. We just use bulk docs for everything because it is capable of handling all those cases just fine. So these are the 4 things that you need to implement to write an adapter for PouchTV and to have it actually be able to replicate. So it's really, really minimal, as you can see, which is kind of a neat feature of our replication algorithm. So what that means is that if we wanted to write a 5th adapter, which, I don't know, maybe we would do. Maybe, we would write an in-memory adapter that doesn't take up as much space as the current memory adapter. Oh, that's right, I didn't explain why that takes up so much space. So the reason that takes up so much space is because the way that memdown is implemented is that it was kind of originally designed for Node.js. And so when it comes to things like, especially binary data, like buffers, it just pulls in the full browser-fied version of the Node buffer module. And I think there's a few other ones that it just kind of pulls in from Node.js. And normally, I mean, we're only using a subset of that API, so really we don't need all that much. So that's kind of a limitation of the InMemory plugin, is that it just takes up so much space, right? It has such a huge footprint, and we're actually only using a small part of that code. But, I mean, we consider those things to be kind of not really for production usage. I mean, like, you can, if you don't mind the big payload coming down, and we certainly test them. All of those adapters are fully tested in Travis, and so if you write one commit that breaks local storage, then we'll know, and we're not going to accept that commit. So we definitely stand behind those things, but they have a big footprint, and I think I kind of more envision them for being cases like where you absolutely have to support IE8 and you hate it and you hate your job because you have to support IE8, but there you go. Or where you want to use the InMemory plugin for something like automated tests, right? Isn't that great? You could spin up Phantom.js and just use PouchTV over InMemory, so it's super fast, right? Because it's not actually saving to disk, and you can run all your tests, and you can test your app as if it was actually writing to disk, but it's not doing it at all. That's really neat, I think. And so for those cases, these things perform admirably, and I don't really have a problem with their size. But if we did want to implement a 5th adapter, and probably first on my list would be to just implement a pure in-memory PouchDB adapter that didn't need to use memdown, just kind of, straight up implementation with just arrays and objects, or ES6 map sets, something like that, then I wouldn't have to actually implement the sync code or the replication code. I would just have to implement the core CouchDB methods, in particular changes, get, revsdiff, bulk docs, and a few other things that are required for things outside of replication, such as all docs, things like that. So code a little bit more in index.js because I think it's pretty fascinating, right? Let's go back to this thing and let's recall just how tiny this is, right? Like this is the entire PouchDB implementation, right? This isn't all the code, obviously it's pulling in a lot of dependencies, but at a high level, this is it. And you'll notice I haven't talked about MapReduce yet, but let's talk about MapReduce now, because this is quite neat, I think. Before I go to MapReduce, let's just mention one more thing real quick, which is that you do notice here that since we have these three main local adapters, LevelDB for Node, WebSQL and IDB for the browser, we only want to include the browser adapters when we actually build the browserfied version. So there is this part here that says if we're not in the browser, then don't include LevelDB at all. So that's pretty straightforward. And then also there's two separate versions of the preferred adapters. So you go into adapters, there's this preferred adapters.js, which in Node will just export a single, an array with a single item, which is LevelDB, because that's the only adapter, the only local adapter. And then in the browser, it's got IDB and WebSQL. So on this, this switch is done in package.json, because I believe in package.json, yes, in package.json with browserify, you can just define browser member, which this is just a map of hey, use this thing in the browserfied version and use this thing in the Node version, and it's pretty minimal, as you can see. And there's promises as well, which I didn't talk about. I can talk about that later. That's kind of interesting. Let's talk about MapReduce next. So I really like the way that we implemented MapReduce. It was actually not my first choice to implement it that way. When Dale and Calvin and I first started talking about implementing, and Neo as well. The four of us started talking about how to implement secondary indexes in PouchDB. This was about a year ago. I just kind of joined the project then. And when we first started talking about it, I really wanted to do native secondary indexes as the first go. And Calvin and I actually did an implementation of that. And Dale pushed back, and I think that actually was the right choice in the end. So he pushed back, and what we ended up doing instead was we had an implementation that just uses PouchDB entirely at the API level. So what that means was that we could actually just include it as a separate plugin, and this MapReduce plugin, all it does is it honestly just when you do query, for instance, and you pass in start key, end key, keys, all those options, like those options are exactly the same between all docs and query. So in the same way that CouchDB, the reason that is in CouchDB is because they implemented all docs on top of query, or on top of MapReduce, let's say. We implemented MapReduce on top of all docs. So you can see that the way this is included here is this is literally just including a plugin. So actually, one thing that's kind of funny here is if you wanted a lighter version of CouchDB or PouchDB and you weren't using MapReduce, just comment this out and do npm run build, and you got a PouchDB that does not include MapReduce. And there's a topic on GitHub where I think I did some measurements about how much space it actually saves. This is kind of interesting. I'll go into this real quick. So, because I was just curious, how much space we could actually save by, say, jettisoning WebSQL. Because, WebSQL is not going to be around for forever, right? So at some point we're going to want to get rid of it. And it's nice to know how much we'll actually save. So I can't remember exactly which issue it was. Maybe I can find it quickly. Yeah, here we go. Well, if I can't find it quickly, I won't waste too much time. I remember the jQuery was in it. Let's see. I wish I could find it. Oh yeah, here we go. Okay, yeah. Okay, here it is. Perfect. So I did some measurements just to see. how much we would save. So if you don't include MapReduce, then the size goes down. Then you shave off about 4 KB. If you get rid of WebSQL, you shave off about 5 or 6 KB. If you get rid of IndexedDB, like you just do WebSQL, I don't know, because you're building a PhoneGap app or something, or a Node WebKit app, that also saves about 5 KB. So there's a lot you can shave off, actually. Like if you're, I think at the very least, the smallest one I could get down to is if you shave off WebSQL and MapReduce, then you can get rid of an entire 10 KB, which is kind of neat. So this is all things you can do. Arguably, we should be exporting this ourselves. Like when we build, we could do like what Lodash and Underscore do, I think, which is build many separate versions, and you can pick and choose the one you want, you know, sort of a la carte. But I think that adds complexity, and so we've kind of shied away from that. But if you want to build it yourself, you know, check out the code, npm install, npm run build. That's all it takes to build PouchTV. Just go into this index.js, comment out what you don't want. If you aren't using replication or something, or you aren't using WebSQL, just comment it out. That's all you have to do, and it'll work, which is kind of neat. So yes, discussing MapReduce a bit more. So MapReduce is a separate plugin, and actually it has no special privileges compared to any other plugin at all. So if you write a PouchTV plugin, you can write something just as full-featured as the MapReduce plugin, which is really, really neat, I think. And I encourage you to write PouchTV plugins. I've got a project called PouchTV Plugin Seed. Which can get you up and running really quickly. And if I can spell plugin. And I've used this to write many, many PouchTV plugins. I literally just check out this code, I fork it, and I start writing on top of that. And it's really, really easy. And this thing is set up so that you can configure Travis to test it. It'll test it in all 3 adapters. All 4 adapters, excuse me. It'll test it. Actually, let's see if we can see the test for this thing. It'll test it in Node.js over LevelDB. Yeah, here we go. Node.js over LevelDB, Firefox, which will be using IndexedDB, PhantomJS, which will be using WebSQL. Then you can test your code coverage too. These are also all testing HTTP. So that's actually a really good thing to test is HTTP, the HTTP adapter. That's good to test not only in Node.js but also in the browser, because sometimes you run into little issues. The old versions of Android have some really weird XHR bugs, so that comes up sometimes. But in any case, so yes, PouchTV plugin. So yes, MapReduce is just a separate plugin. Like you can actually find it if you go to PouchTV/MapReduce, and it's just it's its own project completely. It's just another plugin. So actually, when we deprecate MapReduce, and we are going to deprecate it because we're going to be deprecating it in favor of PouchTV Find, which is based on the Mango query language. So it's a much more simplified way of working with secondary indexes. When we deprecate it, we can actually just comment out that line of code, basically. Like, that's all we have to do, and just stop shipping MapReduce with it. So the implementation of MapReduce is in here as well. And I'm just going to go through the GitHub code. Why not? It's just a little bit easier this way. So as I said, all it does is it just builds up a completely separate database and uses all docs on that separate database. Like when you query it, it just goes into the second database. So this is really great for a couple reasons. It's great for modularity because it totally lives outside of PouchTV, and it just talks to the PouchTV API. It has no special privileges whatsoever. Except there was one thing we had to add for it, which was that we needed a hook to tell it that when its parent database is destroyed, that it too should be destroyed. But that was one very, very special case, and in all other ways, it just talks to the PouchTV API, and that API as well is totally open to any other plugin if they want to use it. So for this thing to work, all it does is listens for changes on the parent database, and then just builds up this second database and just pushes what it needs, pushes the emissions to the second database. So when you write your map function, you write a MapReduce function, and you've got your emit, and you emit some key or some value. That key just becomes essentially the ID of a document in a regular PouchDB database. That's all. That's all it does, literally. The only special thing about that second database is that we use auto-compaction for that database. So you can find that in here, in the MapReduce implementation. I believe it's in Create View. auto compact should we turn on? Yes. So when we create the database, we set auto compaction to true. And the reason we do that is because of how MapReduce is implemented. We don't actually need the rev tree. We don't need the revision tree at all. We only ever have one revision at a time. And so it's perfectly fine to auto compact. One thing about this, though, and I mentioned this in a recent gist where I talked about misconceptions about PouchTV and PouchTV performance, I did admit that the big drawback of this implementation is that it does tend to be pretty slow compared to native indexes. But the upside, and the reason I think that Dale was right to push against me and Calvin when we first did this, was because, man, this has found so many bugs in PouchDB core, and it has helped us improve performance so much in PouchDB core, because this plugin is essentially just a very, very elaborate use case of PouchDB, really, really extreme use case of PouchDB, right? Building an entire second index just using PouchDB documents. And so we've been performance tuning this to hell, and it's really shown in the performance of PouchDB core as well. So as this plugin gets faster, PouchDB core has gotten faster. But I think that recently we have, after a year of working on this, I think we have kind of reached a plateau in about how fast this thing can get. So we are starting to discuss going back to native secondary indexes, and that shouldn't be too difficult to implement because IndexedDB and WebSQL just kind of support it out of the box. LevelDB will be a little bit more interesting, but we can always just have LevelDB fall back to this approach while we work on native secondary indexes for the next one. But yeah, a lot of that is going to wait until after PouchDB find is written as well, because we really want to get that nicer API in, the nice API of PouchDB find, as opposed to the somewhat cumbersome API of MapReduce. So, geez, what didn't I cover? I think that's really all in there. Like, besides the adapter specific stuff, everything else is just kind of CouchDB business logic. Like, there's a whole merge.js, which is probably the file I've touched the least since I joined the project, because Dale, I think he just copied this over from the Erlang code, basically. And this is just the code to, when you update a document in PouchDB or CouchDB, right, you have to do this merge operation of the two trees. Because remember, it's, there's not just one instance of each document at a given time. There's a full tree. It's almost like, imagine every document was its own Git repo or something. Right? There's a full history going back to the beginning of time, and you want to merge these two trees together. And CouchDB has a very, very specific way of merging these things depending on what was deleted and the order of the revisions in lexicographic order. So Dale has implemented all that in JavaScript, and that's in this merge.js. So that's very CouchDB specific kind of business logic stuff. Other stuff in here, it's kind of businessy, is like we got a task queue implementation because we want to make sure to serialize stuff when we talk to IndexedDB or WebSQL. What else? I mentioned the replication algorithm. I feel like this should be in MapReduce. I'm not sure what these two guys are doing here. Maybe those aren't even... I don't know. I don't know what those do. There's the PouchTV constructor here, which is exported, and which is an event emitter. So that's why you can do things like PouchTV dot on error do something. And Calvin implemented all of that because he's the Node.js whiz. What else is in here? The plugins. This is the code that builds the actual like InMemory plugin and local storage plugin. It's really, really minimal. Like for the MemDown plugin, it just says what its name is, right? That string that we passed in, we said adapter memory, how to tell whether it's valid or not, and then what node module it actually uses. You notice that memdown just returns true because it's always valid, because we always are able to save things in memory. But some of them are not that simple. So local storage down, for instance, checks to make sure that we have local storage in this browser, because some super old browsers don't have local storage, or some specific environments, like for instance web workers, don't have local storage, so we can't use it there. Or I think Chrome packaged apps, something like that, I think they don't have local storage. So yeah, so at a high level, the code is really simple, I think, and I feel like it's not that hard actually to get in and get your hands dirty. The hardest thing is when there's a feature that you want to implement that needs to be implemented for all four browsers or all four adapters, and I've done that Oh, I'm starting to run out of videos, so I guess I hope you enjoyed this, and I will hopefully make another video soon. And thank you for watching.